So we'll see how to draw a cam profile using knife edge follower. So in this case, we are taking a 50 mm radius base circle, then rotating clockwise at uniform speed with knife edge follower. So 100-degree rotation for the 40 mm duration, 40 mm for lift. So for the ascent part, then 80-degree dwell, then 90-degree return part. Okay, and you need to draw using UARM motion. Okay, so this is the cam profile, and this is a type of radial type of cam profile, because we are taking line of stroke passing through the center of the camshaft. Okay, so the change is that we are taking a 100-degree. Okay, that is the main important thing. So if the angle is not exactly like 90, 120 and all, so how you need to draw it, so that we'll see. So 100-degree rise part, the 90-degree is the return part, and then total angle which is there, so that will be the remaining for the dwell part. Okay, and the line of stroke which is given there, stroke length total of 40 mm, that is lift, and from this, so displacement diagram, you can take the scale like this. So 1 centimeter equal to 20 degree of cam rotation on the x-axis, and then on the y-axis we can take 1 centimeter as 10 mm, that is lift of the follower, and from there if you take measure the theta naught, it will be 5 centimeter, and then dwell part will be 4 centimeter, and theta r return part will be 4.5 centimeter, and the remaining dwell part will be 4.5 centimeter, and the stroke or lift that is there, that will be 40 by 10, so that will be 4 centimeter. Okay, so like this you can take the scale and then draw the displacement diagram. So initially we'll start with the x-axis, and then we take the dimension on the y-axis. Okay, so here what will happen, angle is 100 degree. So suppose you have to divide it into 6 equal parts, so that you need to get some odd figure. So 100 by 6 if you take is not easily dividable. Okay, so if you divide it exact with some angle, so you will not be getting exactly equal. So for that you will be using line division method. Okay, so let us see how to take this. So first we'll take x and y axis. On that we'll take all the dimensions whatever is given there in the question. So you are drawn first. So first for 100 degree, so we'll take this line by division. So first take in any angle. So if you have to divide that into 6 equal parts, so at any angle you take one line drawn just below, and then so from there you take an equal distances on that line. Okay, mark the 6 equal points on that red color line. Okay, and then when you take the dimension of this all 6 equal parts, then from the last point at the end point you join to the corresponding last point to the in the displacement diagram. Okay, and now this you draw line parallel to the other equal points what you are drawn. Okay, so from there this is the line drawn, so parallel to that. Now we'll take the lines which are will draw parallel to the other points here like this. So once you draw the parallel lines, now automatically you will be getting the equal divisions. So you will be getting 6 equal divisions there. Okay, so whenever there is some odd angles like 100, 110 in between, so you need to take line by division method and then try to divide this. Okay, so once you got this now, so next you have to divide this into 6 equal parts. So draw the line here, and even the lift part also it is an odd distance. Okay, if you directly divide this into 6 equal parts, not easily done. So again that also we will take here. So again 6 equal parts and at any angle, and then join the last end point to the last point there, and then we'll draw parallel lines from that line, so that we get equal divisions of the y-axis also, because that is also an odd one. So like this, if you draw parallel lines, automatically that is divided into 6 equal parts. So this y-axis also at the center part, third one, we have divided it into 6 equal parts. 1, 2, 3, 4, 5, 6 you are given there. Okay, so now after getting these points 1 2 3 4 5 6, so let us draw the displacement diagram using the motion which is given there. Okay, so the motion is UARM motion. So let us join the line now. So first initially you have to take a line that like this. So first to the last point, it will cross the third point there, and similarly the 1 and 2 you have to join from the starting 0 point, and then last also end point to the 5 and 4. Okay, so like this you will be getting the intersection correspondingly, the first one intersection and the second one at the intersection of the second one, and then third already there, and then similarly fourth, fifth, and last one sixth. Okay, so like this you can go on taking the intersection, and when you join this curve you will be getting the displacement, so by using the UARM motion. So now you will join this. So this is the rise part. Okay, so in the same manner we will do the for the return part. So return part, directly angle is given in the easily dividable angle. So if it is not there, that also you can divide this by again taking the line by division. So you take any angle there and equal distance, and then from the last end to join to the last point there, and then draw parallel lines corresponding to the all the points which you are divided. So automatically you will get the equal distance. So 6 equal parts is divided now. So once you get this, then we will draw the lines so that it's all getting 6 equal parts there. So same manner what we have done in the rise part, we will also do for the return part. So we'll start with the return now. So join a line and then draw the same type of curve what we're going to get. So same manner we'll be going to draw a line now. So return also same, join the lines. So you'll get the points like this. So now we'll join the points and draw the curve in the same manner. Okay, so you're getting the curve, and that will complete the displacement diagram. Okay, so this is the displacement diagram using UARM method. So but here we have used the division by line division method, so that whenever there is a angle given which is not dividable by the 6 equal parts, we can draw it. So now you have to measure the distances starting from the base 1 to the displacement what you have drawn, and that length you are going to use in the cam profile. Okay, so let's do with the cam profile now. So now first you need to for cam profile you need to draw the base circle. Okay, so with the given radius of the base circle, let's draw the base circle, and then you have to measure these distances. So what is being given from 1 to A, then 2 to B, 3 to C. Okay, so these distances all you need to measure it and then plot it in the cam profile. So you have to measure all these distances by using a rounder or by using your scale. So scale you need to just take the dimension, and you can by the scale only you can mark the points. Okay, so like this you need to take all the points in the from the displacement diagram. Okay, so you have to measure all this displacement values. Next, once you get all these dimensions, so first you need to see which type of follower is given in the question. So according to the follower, we need to start the construction by that method. Okay, so let us draw it now. So we'll take the dimension. So in that dimension we'll draw the base circle and draw the axis part here, and then we'll take the angle which is measured there. So starting point, let us take the angles. So first one is angle 100 degree, then we have 90 degree dwell part, and then return part you have to take the angle theta r, whatever angle is there, and then once you draw the angles you have to divide this into 6 equal parts, so that much of angle you need to draw it. So let us draw the angles now. So divide this into that much of 100 degree divided by 6 equal parts. So approximately you need to take the angles. So whatever angles you are getting, so that you need to draw it. So one by one you need to draw the angles. So divide this into 6 equal part angles there. So next we'll take for the return part. So that also will divide this into 6 equal parts. So now let us draw the line. So one by one we will get all the angles. So this is for the rise part, it is ascent part. So once you get this, you go to return. Now same way you join all the lines to get the angles divided there. So once you get all the angles, now what you have to do, you have to take the displacement diagram values. So from there you need to mark the distances what you have taken in the displacement diagram. So that distances you transfer it over here. So one by one you transfer the distances. Okay, so complete all the distances measured from the displacement diagram, mark all the points. Now once you mark all the points, as this is the type of knife edge follower, you need to draw the points and mark the points there, and from there you need to draw the smooth curve. Okay, once you draw the smooth curve, you will be getting the cam profile. So getting all the points there, and then you need to trace the cam profile with all these points. Draw a smooth curve with all these points. So don't use the scale and draw straight lines. You have to draw the smooth curve. So with all these points, whatever you getting, so that you get a smooth curve. So once you get know all the points, let's draw the cam profile like this. So we'll be getting the profile like this. So you can label it. So the red color cam profile can be seen there. So the inside circle is known as the base circle, and the path you have traced, that is the red color, that is nothing but the cam profile. So label it properly. So whenever in the exam you need to show that angles what you have taken, what